Last time I introduced a video, I was in Costa Coffee, and here I am again in Costa Coffee. No connection, not a commercial for Costa Coffee. There are other brands available, but I'm going to talk today about a new antenna I've been experimenting with. Simple antenna, something you can make yourself, so it's not going to cost you too much. Anyway, take a look, see what you think. Well, welcome once again to the Waters and Stanton video channel. Thank you for joining me. If you've got a modern HF transceiver, the chances are that it might just have 4 meters and 6 meter coverage on it. Now, there's also a good chance that you haven't got an antenna for 4 meters and 6 meters. You may think, well, I can't really justify it. I'm not really sure what's on the band. I've heard that they're not particularly busy, therefore I'll give it a miss. Well, what I've decided to do was to come up with a design for a very simple antenna which will enable you to operate on both 4 and 6 meters, at least gets a flavour for it. It's basically a multi-band dipole. It's very easy to make, and it'll give you a chance to check the band from time to time, or the bands from time to time, to see whether you want to go further on those two bands. There are activity nights organised by the RSGB, and of course you're probably aware that the 6 meter band can open at certain times of the year in a dramatic way. Sporadic E is one of the favourite propagation forms on the 6 meter band. It usually occurs in spring from around about April through to around about June, and there's another secondary opening at the end of the year around about December, January. But also, because we're at sunspot maximum, it's highly likely that 6 meters is going to be very exciting this winter, particularly around about October, November time, December time. There could well be some openings to the USA. So it's a good chance to get something up for 6 meters just in case. And there are other periods of activity. I mean, there are some clubs that are active on 6 meters and of course on 4 meters. So anyway, the purpose of this video is to give you some brief details of an antenna which I've called the quick dip antenna. Why have I called it the quick dip antenna? Well, precisely, it gives you a chance to dip your toes into 4 meters and 6 meters to see whether it's for you, and of course to check for local activity from time to time. Of course you can get sporadic E on 4 meters, not so common, but it does occur, and it can be equally as exciting as 6 meters when it happens. Anyway, without further ado, let me describe this quick dip antenna that will cover 4 meters and 6 meters, something that you can easily make very low cost. Let's have a look. We're going to use something called parallel dipoles. And the first one here is the 6 meter dipole, and then underneath we're going to have a 4 meter dipole. There's the 4 meter dipole there, and we need to strap these two antennas together at the feed point, and we're going to directly feed this with coax cable. The inner conductor goes to one side and the sheathing goes to the other side. Now this is quite a short dipole because we're on the edge of VHF, and so the measurements at either end are going to be fairly critical, and I'll come back to that in a moment. If you're looking for a really great performing HF transceiver that covers 6 meters and 4 meters, doesn't cost too much money, and has a superb receiver performance, then check out the Yaesu FT710. It's a great transceiver, either the field model or the AESS. The easy way to make two parallel elements for 4 meters and 6 meters is to use 450 ohm ladder line. At the center of the antenna, each length of ladder line is shorted so that the elements are in parallel, and I used an available connector to do the tests. In order to provide some strength for the centre of the antenna, I used a length of plastic material and just bound it to the two pieces of ladder line just to give it some rigidity. You can't really use a conventional insulator for the ends because we're talking about something which is near VHF and very sensitive to adjustment. So I simply made a loop at the end and then attached a length of cord for the support. Now I've put up on the screen here the actual overall length of the antenna. The length of the 6 metre one is obviously longer than the 4 metre one, and you do need to add a little bit extra just to give yourself a bit of leeway when you're making adjustments, because it's far better to have the antenna slightly too long and therefore slightly too low in frequency than the other way around. So I suggest you add perhaps a centimetre or so to each length just to give yourself a bit of leeway if you have to make some adjustments. Now let's have a look at the VSWR that we got with this antenna. It's handy if you've got a antenna analyzer of some sort. I use the Zoom antenna analyzer. I'm not sure you can see this in the sunlight, but I use the Zoom antenna analyzer, and I'll show you a close-up now of the VSWR that I achieved once I'd resonated the antenna. Now here's a close-up of the Zoom analyzer. There's a blue stripe on the left-hand side which indicates the 6 metre band, and you see I've resonated the antenna right at the bottom. In fact, it could be nudged up a bit. And on the right-hand side, you've got the 4 metre resonance, and you can see in both cases very respectable VSWRs. You couldn't wish for anything better than that. I must apologise for the quality of the photo there. It was shot through the Perspex rain cover of the analyzer. And here's the antenna laid out on my lawn. You can have the antenna as a horizontal dipole, or you can have it as a vertical dipole. The advantage of having it as a vertical dipole is that it becomes omnidirectional, and that may favour you for general listening. But anyway, it's a personal choice. I should mention that you don't need to carry the ladder line any further than the 4 metre section. The final 6 metre section can be completed by using a length of flex, as I've shown here. So there we are. That's the quick dip antenna for 6 and 4 metres. A chance for you to try out those bands and see what you can hear, and see whether it's something that you may want to develop in your station and put up perhaps a small Yagi. We do Yagis for 6 metres and 4 metres, so please check our website. And of course, we sell 450 ohm ladder line, so no problem there. So I hope this has been helpful to you. Oh, by the way, the unit I used in the centre, that is readily available on our website as well, but you may have other ideas. All you need is a method of connecting coax to the element. I avoided using any form of balun because I didn't find it was really necessary, and in any case it's difficult to find a balun that will be suitable for the higher band, the 4 metre band. But what you can do is to just wind a few turns of coax at the feed point into a coil, say about 4 turns of coax in a coil at the feed point would act as a balance both for a balun rather. So there we are. So thank you for watching this video. I hope it's given you some ideas, some chance to do some experimentation. Doesn't really cost much at all, and you may well have some fun on these rather too interesting bands. In the meantime, thank you for your support on this channel. It's much appreciated. And as usual, I look forward to seeing you in the next video. Bye for now.